All right, let's dive right into this explainer because today we are looking at one of the absolute most fascinating everyday mysteries of our world. Just think about that simple little fridge magnet holding up your grocery list. Have you ever actually stopped to wonder how it works? I mean, it has no batteries, there are no wires plugged into it, it uses literally zero fuel, and yet this completely ordinary looking object has this invisible power to just reach out and pull another piece of metal right toward it. For centuries, folks looked at this and genuinely wondered, is this magic? Is it some sort of scientific illusion? Or is there a hidden energy locked inside there? Well, I can tell you that the invisible pulling power of magnets didn't just give us the compass, it completely and entirely revolutionized modern technology. As we're going to uncover today, this invisible force is the very beating heart of the motors, speakers, MRI machines, and even the hard drives storing our digital lives. Now, our understanding of all this definitely didn't happen overnight. About 2,500 years ago, over in a place called Magnesia in ancient Greece, people discovered this bizarre rock that just naturally attracted iron. They called it lodestone, which we now know is a mineral called magnetite that contains iron oxide. Fast forward to between 200 and 100 BC, and the Chinese civilization was already unlocking its practical power. They carved lodestone into the shape of a spoon, placed it on a smooth bronze plate, and noticed it always pointed north and south. This was the world's first compass, and it shifted humanity from just localized sailing to massive oceanic navigation. Then, in the year 1600, an English scientist named William Gilbert published De Magneti, proving a totally revolutionary concept. A compass needle points north because the Earth itself is a giant magnet. You know what's really wild, though? The origin of the word magnet itself. According to an ancient Greek legend, there was a shepherd named Magnus. One day, he's walking along a rocky hillside wearing shoes that just happen to be fastened with iron nails. Suddenly, his feet mysteriously stick to the ground. The earth beneath him was packed with natural magnetite. Now, while historians debate the absolute truth of this little story, it perfectly captures how magical and honestly baffling this invisible force was to early humans, and it gave us the name we still use today. Okay, so to understand why this isn't actually magic, we have to zoom way down to the atomic level. The crucial key here is something called magnetic domains. You can kind of think of these as billions of microscopic mini-magnets living inside the material. Magnetism is actually the direct result of how electrons move and how atoms align. It turns out every single electron has its own tiny magnetic moment. When vast numbers of atoms start pointing in the exact same direction, boom, a unified magnetic field is born. The difference between an ordinary piece of metal and a magnet really just comes down to chaos versus order. Inside a normal piece of iron, those microscopic domains are pointing in totally random, chaotic directions. And because they're all pointing different ways, their microscopic forces just completely cancel each other out. But inside magnetized material, those domains are forced to align in exactly the same direction. They essentially team up, pooling all their tiny invisible forces together to create one incredibly strong magnetic field. And hey, this perfectly explains why magnets don't just stick to everything in your house. Only certain materials, known as ferromagnetic materials, have the right internal structure. Elements like iron, nickel, and cobalt have atomic domains that are naturally flexible enough to be easily aligned by an external force. On the flip side, materials like wood, plastic, gold, or aluminum completely lack this atomic flexibility. You could expose a wooden block to the strongest magnetic field on the planet, and it simply won't care. It'll be completely unaffected. So today, we categorize this phenomenon into three main types of magnets. First, permanent magnets, which maintain their aligned field over a long period. Think of your trusty fridge magnets. Second, temporary magnets, which only act like magnets when they are placed inside an existing magnetic field, which is a neat trick used for a lot of industrial tools. But the third one is where human ingenuity really shines, electromagnets. By running an electric current through a coil of wire, we literally create a magnetic field. If we slip an iron core inside that wire coil, it multiplies the strength exponentially, creating ultra-powerful magnets we can control at will. Section 1. Forging modern supermagnets through extreme engineering. Let's move on and see how this works. So by mixing three highly specific raw materials, neodymium, iron, and boron, scientists developed permanent magnets that are, frankly, unbelievably powerful. They can hold hundreds of times their own weight. These are not the weak little magnets holding up a child's drawing. These are the absolute workhorse components that make our modern world possible, actively powering the ultra-efficient motors in electric vehicles and spinning the massive turbines on wind farms. But how do you actually make one of these things? Well, it is an intense, highly engineered factory process. First, these raw materials are melted together in an induction furnace at extreme temperatures, and then quickly cooled to get the exact right crystal structure. Second, this hardened alloy is crushed down into an incredibly fine powder. But here's the crazy part. That powder isn't magnetic yet. Third, they put the powder in a mold and blast it with a strong external magnetic field to force every single tiny microscopic domain to align perfectly. Fourth, they compress it and put it into a sintering furnace, heating it just enough to bond the powder into a solid, dense structure without actually melting it. Finally, a dedicated magnetizing machine blasts it one last time to give it its full, staggering strength. Now, engineering always involves trade-offs, right? The crucial point here is a truly fascinating engineering hurdle. Despite holding immense power, these supermagnets are actually highly brittle, kind of like glass. They're also really prone to corrosion. If two neodymium magnets were to snap together from a distance, the sheer force of their own attraction could literally shatter them into pieces upon impact. To solve this, manufacturers have to carefully coat them in layers of nickel, zinc, or protective epoxy just so they remain durable and rust-free. As we look at all these advanced materials, it really helps to zoom back out to the basic principles we all learned back in grade school. Every single magnet, no matter how powerful or how tiny, operates on the rule of poles. Opposite poles, north and south, attract each other, while identical poles, north and north, or south and south, violently repel each other. Why does this matter? Because this absolute, predictable rule of push and pull is the fundamental foundation of every single modern electric motor and generator on the planet. Section 2. Powering the modern world and modern applications. Let's see how this shapes our lives. The modern world as we know it truly kicked off in the 1820s, thanks to two brilliant scientific minds. Hans Christian Ørsted proved that electric currents actually create magnetic fields. And then, shortly after, Michael Faraday proved the reverse, that a moving magnet can actually generate electricity. They proved that electricity and magnetism aren't entirely separate forces at all. They are essentially two sides of the exact same coin. This single, massive revelation birthed the electric motors humming inside your washing machine, the starter in your car, the speakers in your phone, and the ceiling fan over your head. To see just how far this tech has come, you really only have to look at your local hospital. MRI stands for magnetic resonance imaging. These machines use superconducting electromagnets to generate fields that are thousands of times stronger than the magnetic field of the Earth itself. By safely manipulating the tiny magnetic signals inside the atoms of our bodies, doctors can look deep inside human tissues and organs in high definition without making a single surgical incision. Magnets have quite literally become a profoundly life-saving medical technology. And out in the industrial world, the scale is just as mind-blowing. If you've ever seen those massive scrapyard cranes effortlessly lifting entire car bodies into the air, it straight up looks like magic. But it is driven entirely by electromagnetism. Thousands of kilos of solid steel are hoisted into the air when a simple electrical switch is turned on, instantly aligning the magnetic domains. When the operator needs to drop the car, they just flick the switch off. The electricity stops, the field collapses, and the metal drops. It is so elegantly simple yet incredibly powerful. Then there's transportation. 600. That is the staggering top speed in kilometers per hour of advanced maglev trains. Maglev stands for magnetic levitation. These trains utilize insanely powerful magnets to literally float the train in the air, meaning the train never actually touches the tracks. By utilizing that repulsive force of identical magnetic poles we talked about, they reduce physical friction to near zero, allowing for smooth, silent travel at speeds that rival airplanes. I do have to add an important note of caution here, though. This incredible invisible power demands intense respect and strict handling requirements. The immense strength of modern supermagnets means they carry some pretty severe risks. Getting too close to a strong magnet can fatally disrupt pacemakers and other sensitive medical devices. They can instantly erase hard drives and data storage devices. And tragically, they are extremely life-threatening if multiple small magnets are accidentally swallowed by kids, because they can pull together right across intestinal walls with catastrophic force. So yeah, this invisible power requires immense respect and careful handling. So as we wrap up this explainer, I want to leave you with a fascinating thought to ponder. How did an ancient, magical stone picked up by a Greek shepherd become the invisible backbone of modern civilization? We've seen how centuries of curiosity, quantum physics, and extreme engineering took what early humans believed was pure magic and turned it into a highly controlled scientific miracle. Magnets gave us our first sense of global direction, they give us our energy, and they actively power our future. So the next time you use your headphones, or hear a train, or even just stick a note to your fridge, take a second to appreciate the invisible forces that are silently running our world. Stay curious.